We're back with example 1 continued. All right, so once you have an R value, you want to test it to see if it's significant enough to indicate a linear relationship of some kind. Now, this particular question says, at the 5% level of significance, is there a significant negative linear relationship? So here's the idea behind that. Now you need to remember that when you do a hypothesis test, your hypothesis involves your population. We already know the correlation for the sample of 6 students. So hypotheses always involve your population. So the point is, we're doing a hypothesis involving the correlation for the entire population, which I want to remind you is called rho, the Greek letter rho. All right, kind of looks like a P, but not quite. Anyway, you see it on your printout. So let's think about this. Here's the general idea. You assume there is not a linear relationship. That's what we will be doing on all of these. So if you think about it, if there's not a linear relationship, you're going to assume that that correlation for your entire population, which is called rho, would be equal to 0. So there you are again with your null hypothesis. And I will just tell you on the 2 that I'm having you do, that will be your null hypothesis. You're assuming that these 2 variables do not have a linear relationship, which means that the correlation for your entire population would be equal to 0. So there again would be the idea behind our general test of significance, your null equals, all right? Now, your alternative, as we've said before, could be any of these 3, and I would take you back to the fact that this question wanted us to test whether or not there is a significant negative linear relationship. So wouldn't your correlation, if you're going to be significantly negative linear, be less than 0? So that's the key wording there. If you're going to prove that there's a negative linear relationship, if you're going to test that, negative linear, your correlation would have to be significantly less than 0. All right? So again, those are key words, negative linear. If we're going to try to prove it was a positive linear, if the scatter plot suggested positive linear, greater than 0. Okay, so that's this whole picture back here. Test statistic. It turns out that when you do a test involving correlation, it is always the same. T equals da-da-da-da-da. I've written it on the board. And by the way, T also involves degrees of freedom, which in this case is n minus 2. There's a mathematical reason for that. We have 2 variables instead of 1. Anyway, just go with it. That's very high-level stuff there that I'm not sure I could even explain. So there you go. Then we're going to make our rejection region and decision rule based on whether it's a lower tail, upper tail, or a 2-tail. And this will involve the T. So we've got our T table here, our T curve. And they want us to use, back to the question, 5% significance. So alpha will equal 0.05. And because of the less than, which all goes back to the question of, is there a negative linear relationship? Right, negative on the lower side. We're putting 5% in that lower tail. And then keep in mind that the other element involved in doing a t-test is degrees of freedom. And our degrees of freedom here would be the fact that we had 6 data points minus 2, 4 degrees of freedom. So going to our friend the t-table now. Here we go. Let's do the t-table. And again, all this is because we're testing R. That's why I'm leaving this on. And so we're doing a 1-tail, lower tail. So we go to the 1-tail, 5%, 1-tail, 5%, and combine that with 4 degrees of freedom. And I think our statistical cutoff here would be 2.132. I'm checking again, 2.132. So, and that will be negative. Look, if you're below 0, you're negative. We've had that discussion many times. You're on the lower side of the curve. Reject the null hypothesis if t in the next step, when we plug numbers in this, ends up being less than the negative 2.132. All right, and I'm keeping all this up here because we need it for later on. I apologize again for squeezing things, but I've been watching the videos. I think they're okay. I don't know. You might have to watch them on a fairly large device. Probably not too good on your phone, I bet. All right, t equals r. See, we get that r value from our data. That beautiful formula we crunched out earlier. Negative 0.928, I want to remind you. Negative 0.928. Square root n, 6 data points, minus 2 over 1 minus. Okay, here's where a really common mistake happens. When you put that r value into this formula, make sure you put it in parentheses, negative 0.928 parentheses squared. If you don't put it in parentheses when you put it in your calculator, it's not going to come out the same. Fair warning, we yell about that in algebra, we yell about that in here, but that negative 0.928 in that formula, make sure you put it in parentheses, and make sure you put it in parentheses when you square it in your calculator. And break this into steps, crunch this and write it down, crunch this and write it down, divide them, square root. It's order of operations. I'm not sure what else to say. So, that t value, and here he goes, Mr. Snob again. Mr. Snob again. That would be another name for me, wouldn't it? That should crunch out to be, as you continue reading the notes, negative 4.98. And, ready, Snob?
It's just arithmetic, order of operations.
Don't you like that scrunchy face? All right, so negative 4.98, and if you look at your picture, like we've done on these tests before, you will see indeed that that's out there in that lower rejection region. It is indeed less than this number, so you're going to reject the null hypothesis. All right, so wouldn't the decision be just that, to reject the null hypothesis? So you say, okay, null hypothesis, I gave the benefit of the doubt, the majority of the distribution, to the assumption that they're not linear. But there was enough evidence to reject you in favor of, yeah, you know what? These aren't in a perfectly straight line, but according to the statisticians, indeed, a negative linear model would be a good approximate substitute for that data. So, just like the question was worded, at 5% significance, is there a significant negative linear relationship? Yes. But don't just put yes. Take that question and make it into an answer. All right? So, indeed, there is a significant negative linear relationship. Now, there's another part to this, which we will now delve into. Since that test came out, that there was indeed a linear relationship close enough, we're about to delve into the last step of this, which would be, okay, then what is the equation of that line that would be best appropriate? It's called the line of best fit, and we're going to pause now and erase the board and do part 3 of this question, whereby we determine the equation of the line that the statisticians say would be the best model for that data. So, hang on, we're ready to come back for part 3.